Good evening. We start with sum number 7. Find the coordinates of the circumcenter of the triangle whose vertices are A minus 2, 3, B 6 minus 1 and C 4, 3. Basically, what is circumcenter? It is point of intersection of three perpendicular bisectors. But in this case, we need not find all the three. Why? It is sufficient to find only two perpendicular bisectors. Third has to pass through point of intersection of these two, right? So consider any two perpendicular bisectors. Let P be the circumcenter of triangle, that is point of intersection of three perpendicular bisectors. Let PM and PN be perpendicular bisectors of sides BC and AC. Now to get the equation of PM, we need two things: slope of PM and coordinates of either P or M, but we do not know coordinates of P. Where to find those coordinates only? But M is midpoint of BC. So by midpoint formula, we can get coordinates of M. Slope of BC is say M, then slope of PM will be minus 1 upon M because PM is perpendicular to it, right? Similarly, we can obtain equation of PN. By solving two equations, we get P, which is nothing but circumcenter. So M is phi 1 and N is 1, 3. M and N are the midpoints of BC and AC. So slope of BC is minus 2. As PM is perpendicular to BC, slope of PM, perpendicular bisector, is half. Now we know the coordinates of M. So what is equation of PM? Y minus 1 equal to half x minus 5. That is x equal to 2y plus 3. Now what is slope of side AC? 0. This means AC is parallel to x-axis. Now PN is perpendicular to AC. So PN will be parallel to y-axis. See, y-axis has no slope. So usual method of this is the slope, this is the point. So equation will not work. Now this is parallel to y-axis. So its equation is of which type? X equal to constant. Now 1, 3 lies on this line. So coordinates will satisfy the equation. That gives me A equal to 1. So what is that? Perpendicular bisector. Its equation is x equal to 1. Put this in equation 1. That gives me y equal to minus 1. So what is the circumcenter of triangle? It is 1 minus 1. Now sum number 8 for homework. Find the coordinates of orthocenter. We already done one sum of this type. Orthocenter of the triangle whose vertices are. Now the answer is 5 by 3, 2 by 3. Sum number 9. Show that the lines 3x minus 4y plus 5 equal to 0, 7x minus 8y plus 5 equal to 0, and 4x plus 5y minus 45 equal to 0 are concurrent. Find their point of concurrence. I have explained two methods. You may say, sir, determinant method is the simple one. Yes, I agree. But in that case, you will have to find point of concurrence separately using Kramer's rule or any other method. So which is the other method? See, what is concurrency of three lines? If three lines intersect in only one point, then lines are said to be concurrent. So what we can do is, we will solve any two equations, okay? And we will show that the point of intersection of lines representing those equations lies on the third line also. So lines are concurrent. The advantage of using this method is we already know the point of intersection which is asked, okay? Okay, we'll use both the methods. Chalo. Write down. The lines are, write down, 3x minus 4y. I will rearrange the term, see whether you can get this or not. 3x minus 4y equal to minus 5. Then 7x minus 8y. 7x minus 8y is minus 5. And third equation, 4x plus 5y equal to what? Is it 45? Yes, it is 45. So these are the three equations representing three lines. Now it can be seen that first and second can be solved easily. 1 into 2, therefore 6x minus 8y equal to minus 10. This is number 4. 2 minus 4 gives. I'm solving two equations. I'm not saying this is the only possibility. You can go for second, third, first, third. That is your choice. 2 minus 4 gives us 7x minus 6x, that is x. Then minus 5 plus 10. So I have got x equal to 5. Put in 4 or 2 rather, not 4. Therefore 7 into 5 minus 8y equal to minus 5. So what is 8y? 8y is 40. So y is again 5. Okay. So I will say first two lines intersect in 5, 5. Okay. Now we have to verify whether these coordinates satisfy equation 3 or not. Okay. Put x equal to y equal to 5 in equation 3. Why equation 3? Because we have solved first two equations. So what is LHS of equation 3? It is 4x plus 5y. So 4 into 5 plus 5 into 5. Is it 45? Yes, same as RHS. Therefore, 5, 5 lies on third line also. On third line also. Therefore, lines are concurrent. As I said, what is the advantage of this method? What is the point of concurrence? 5, 5. Lines are concurrent. Point of concurrence is 5, 5. Right now, this is the first method. Now we discuss two important things, in fact three. The first one is length of perpendicular from origin on the line ax plus by plus c equal to 0, or we can say that distance of the line from origin. Secondly, length of perpendicular from any point, say p x1 y1 on the line ax plus by plus c equal to 0. And the third interesting part is distance between two parallel lines. So the first part, length of perpendicular from origin on this line. This is the line and we are interested in this length of perpendicular, say OP. Okay. Now given line is ax plus by plus c equal to 0. I write this as ax plus by equal to minus c. I assume that this is greater than 0. If this is not greater than 0, then I will have to write this as minus ax minus by. But anyway, we are going to consider modulus at the end. Okay. Now I compare this equation with x cos alpha plus y sin alpha equal to p. Now you will ask me, sir, why to compare this equation with this one? For the simple reason, in x cos alpha plus y sin alpha equal to p, what does p stand for? P represents length of perpendicular from origin on the line, and we are interested in finding that only. Okay. If two equations represent the same line, then their coefficients are, don't say equal, they can be, but they need not be. Coefficients are comparable. Again, I will give the same simple example. X plus y equal to 1 and 3x plus 3y equal to 3. These equations are the same. So will you say 1 is 3, 1 is 3, 1 is 3? No, 1 upon 3 equal to 1 upon 3 equal to 1 upon 3. So if two equations represent the same locus, we can say then their coefficients are comparable. So cos alpha upon A equal to sin alpha upon B equal to P upon minus C. Now we eliminate alpha. So what is cos alpha from first and third? Cos alpha is AP upon minus C, that is minus AP upon C. What is sin alpha? Minus BP upon C. On squaring and adding, we get cos square alpha plus sin square alpha, which is eventually 1, equal to A square P square upon C square plus B square P square upon C square. Take P square upon C square common to get this. So in the next step, I will say 1 equal to P square into A square plus B square upon C square. We are interested in finding P. So I rearrange the terms. So what is P square from this? It is C square upon A square plus B square. Now take roots on both the sides because we are interested in length of the perpendicular. So P is what? See what I am writing. Mod of C upon root A square plus B square. We are sure about denominator root A square plus B square. It cannot be negative. But what about C? So we are not sure about the sign, but distance is never negative. So we say that it is mod of C upon root A square plus B square. Right? You have to remember this formula. This is the simplest proof in the textbook. The proof given is complicated. In that case, they have obtained area of the triangle using two different methods and equated the lengths. I think in exam, if you use this method, then also you will get full marks. So the result can be remembered easily. If you haven't understood the proof, time being, just remember the result, that length of perpendicular from origin on ax plus by plus c equal to 0 is modulus of constant term, whatever may be the constant term, upon root of square of the coefficient of x plus square of the coefficient of y. Okay, so this is the formula. Now every time perpendicular will not be drawn from origin. Suppose perpendicular is drawn from Px1y1 on the line ax plus by plus c equal to 0. Then what is the length of that perpendicular? Of course, to find that, we have to use first result only. And that is why I have asked you to remember it as it is modulus of constant upon root of sum of the squares of coefficients of x and y. Now we have obtained that result for length of perpendicular from origin. And therefore, what we do is we shift the origin to the point from which perpendicular is drawn. That is, we shift the origin to which point? X1, Y1. See, I have not shifted the point from which perpendicular is drawn. I have not shifted that line also. Okay. Suppose P is length of the perpendicular. Now, what are the formulae for shift of origin? Old coordinate is new coordinate plus coordinate of shifted origin. So small x is capital X plus x1. Small y is capital Y plus y1. So the equation of the same line becomes a capital X plus x1 plus b capital Y plus y1 plus c equal to 0. Rearrange the terms. Ax plus by plus ax1 plus by1 plus c equal to 0. Note that we will be given x1, y1. So x1, y1 are constants, right? Now, what is the length of perpendicular from origin, new origin to the line? Simple, mod of constant. This part is constant upon root of coefficient of x is a and that of y is b. So root of a square plus b square. Yes. So this is the formula to find length of perpendicular. drawn from x1 y1 on this line ax plus by plus c equal to 0. Suppose x1 y1 is 0 0. See whether we get the same result or not. Yes, we get. Put x1 0 y1 0. So it is mod of c upon root of a square plus b square. Now we discuss how to find distance between parallel lines ax plus by plus c equal to 0 and ax plus by plus c dash equal to 0. See, lines are parallel. So it will be ax in both the cases, both the equations, and by. Or if it is 2ax plus 2by, then we'll have to divide by 2 first, right? Now logic is very simple. Take any point on any of the two lines. Suppose I select this line. Take any point on this line. For convenience, I will say put y equal to 0. So what is x? Minus c upon a. So minus c upon a 0 definitely lies on the first line. Now find length of perpendicular from this point on the other line, which is nothing but distance between parallel lines. We have just proved that formula. It is mod of ax1. A is a only. What is x1? X1 is x coordinate of the point from which perpendicular is drawn, minus c upon a, plus b y1. Y1 is 0 plus constant term, perpendicular is drawn on this line. So c dash upon root a square plus b square. Here a gets cancelled. So c dash minus c upon root a square plus b square. Or we can say, as we have taken modulus, mod of, instead of saying c dash minus c, we say c minus c dash upon root a square plus b square. Okay. Or you may say, sir, we will find length of perpendicular from origin on both the lines, and the modulus of the difference is the required distance. That is also correct. In fact, effectively this is the same. Give the title length of perpendicular from origin. Give the title length of perpendicular from origin to the line ax plus by plus c equal to 0. Length of perpendicular from origin to the line ax plus by plus c equal to 0. In that, write down the length of perpendicular from origin to the line ax plus by plus c equal to 0. Ax plus by plus c equal to 0 is, see on the screen, ohm, because I have drawn this diagram, equal to mod of c upon root a square plus b square. Right up. If you want, you can draw this rough sketch also. So the length of the perpendicular, it is mod of c upon root a square plus b square. How to remember this? It is always modulus of constant term upon root of sum of the squares of coefficients of x and y. Okay. Now, next part. In that we will write directly. Leave one or two lines and then write length of perpendicular the length of perpendicular from p x1 y1, from p, capital P x1 y1 on the line ax plus by plus c equal to 0. Ax plus by plus c equal to 0 is Pm equal to, right, Pm equal to mod of ax1 plus by1 plus c upon root a square plus b square. Okay. Now leave one or two lines and then give the title, the distance between two parallel lines. The distance between two parallel lines. The distance between two parallel lines. In that, write down the distance between parallel lines. The distance between parallel lines. See the equations. Ax plus by plus c equal to 0 and ax plus by plus c dash equal to 0 is mod of c minus c dash upon root of a square plus b square. Right up. Now in the textbook, I think they have considered C1, C2 instead of C and C dash. Same logic. Okay. After that, write down note. Note. Coefficient of x is the same in both the equations. Coefficient of x is the same in both the equations. And so is coefficient of y. And so is coefficient of y. Now sum number 11. Find the distance of the origin from the line 7x plus 24y minus 50 equal to 0. So what is that formula? It is mod of constant, that is mod of minus 50 upon root of sum of the squares of coefficients of x and y. So on simplification, you get 2 unit. Sum number 12. Find the distance of the point A minus 2, 3 from the line 12x minus 5y minus 13 equal to 0. So what is the formula? Mod of ax1 plus by1 plus c upon root a square plus b square. You should be able to write the values. What does a stand for? Coefficient of x in the equation of line 12. x1 is x coordinate of the point from which perpendicular is drawn. B is coefficient of y in the equation of line. y1 is y coordinate of the point from which perpendicular is drawn, and c is constant. Okay, so you get 4 unit. Sum number 13. Find the distance between parallel lines 4x minus 3y plus 5 equal to 0 and 4x minus 3y plus 7 equal to 0. First see that coefficient of x is the same in both the equations. Yes, so that coefficient of y will also be the same if lines are parallel. See, if lines are intersecting, then there is no point in finding the distance between them. It ranges from 0 to infinity, right? So what is the distance? Mod of c minus c dash upon root a square plus b square. Substitute the values to get 2 by 5 as the answer. 2 by 5 unit. Sum number 14. Find the distance between parallel lines 9x plus 6y minus 7 equal to 0 and 3x plus 2y plus 6 equal to 0. See, we cannot use the formula directly because coefficient of x is not the same. There are two options. Either divide first equation by 3 or multiply second by 3. Now it is better not to deal with fractions. So I will multiply second equation by 3 throughout. And that is why I have written these are the parallel lines. That is, this equation as it is, multiply both sides of the second equation by 3. Now apply the formula. So mod of -7 minus 18, you have to change the sign, upon root of 9 square is 81, 6 square is 36. So addition is 117. Now what is 117? It is 9 into 13. Root 9 is 3. So this is the final answer. So enough is enough. We'll solve the next sum in the next lecture.